Hello everyone, today we'll be covering rational functions. This is the last part of the video trilogy on drawing functions. Rational functions are functions that have a polynomial as a numerator and denominator. We'll only be studying rational functions with a linear denominator, so basically a denominator in the form ax plus b. Let's dive right in. We have three different types of cases that we'll be learning. The first case we have is a constant numerator, k, over ax plus b. For this graph, we immediately know that there's a vertical asymptote at x equals to negative b over a, over here. And why is this so? We know that ax plus b cannot be equals to 0. So hence, the vertical asymptote has to be at x equals to negative b over a. The next feature of this graph is the horizontal asymptote at y equals to 0. That is true for any value of k. Now, I want you to focus on the red function first. If k is more than 0, this means that the graph will appear in quadrants 1 and 3. In case you forgot, this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. So again, if this value of k is more than 0, then the graph will appear in quadrant 1 and quadrant 3, as seen by the red graph. However, if k is negative, then the graph will appear in quadrant 2 and quadrant 4, as seen by the green graph. If you look at the shape of the graph properly, let's just look at the red graph. The red graph tends to the asymptotes at both sides. Look at this, it's tending to the horizontal asymptote and tending to the vertical asymptote on both sides of the graph. Similarly, for the green graph, the graph is tending to the horizontal asymptote here, and the graph is also tending to both sides of the vertical asymptote. Now the second case is when we have a linear numerator, px plus q over ax plus b. Again, we know that we have a vertical asymptote at x equals to negative b over a because our denominator cannot be equal to 0. To find the horizontal asymptote, we actually need to do long division. After the long division, we will get something in the form of c plus k over ax plus b. And we can immediately identify y equals to c as your horizontal asymptote. But if you're feeling lazy, you can just read off the horizontal asymptote, p over a. P over a. So let's test this out. Let's say we have 2x plus 1 over x minus 1. Our horizontal asymptote is just p, which is 2, over a, which is 1. So our horizontal asymptote is just y equals to 2. We can still do our long division though. And for the benefit of those who are not familiar with long division, let's do it together. So we have 2x plus 1 divided by x minus 1. What we want to do is find something that when we times, we'll get this x to match this 2x. So what times x will match 2x? It's just 2. So we'll put a minus sign here and then multiply everything by 2. 2x minus 2. And then we'll get 1 minus minus 2, which is just 3. So how we write this is just 2 plus 3 over x minus 1, with your remainder being up here, and this thing over here written over here. Again, the value of k, or in our case, the k over here, which is k equals to 3, would determine where the graph would be. So for k is more than 0, again, let's look at the red graph. The two parts of the graph will be in quadrant 1 and quadrant 3. However, if k is less than 0, look at the green function, the graph will be in quadrant 2 and quadrant 4. The final case is when we have a quadratic numerator, px squared plus qx plus r over ax plus b. Once again, we know that we have a vertical asymptote at x equals to negative b over a, over here. Now similar to the previous case, we also want to do long division. After long division, we will get this function, cx plus d plus k over ax plus b. Earlier, y equals to c will be your horizontal asymptote, but we have this cx plus d over here. Now, this is a new type of asymptote, known as the oblique asymptote. Y equals to cx plus d, or this linear line over here, will be your oblique asymptote. Again, similar to other cases, for k is more than 0, the two parts of the graph will be in quadrant 1 and quadrant 3, as seen by the red graph. And note, this part is quadrant 1, this part is quadrant 3. This part is quadrant 2, and this part is quadrant 4. Similarly, the shapes of the graphs will again be tending to the asymptotes on both sides. Let's look at the red case where k is more than 0 first. So if we look here, the graph is tending to this oblique asymptote and tending to this vertical asymptote. And over here, the graph is tending to this vertical asymptote and this oblique asymptote over here. A similar thing is happening for the green graph, which is when k is negative. So let's do one practice. Let's say we want to draw the graph of 2x squared plus 3x minus 7 over x minus 1. So what we first want to do is do long division. Again, what matches x to become 2x squared? We need to times this by 2x. So we minus this whole thing and becomes 2x squared minus 2x, which will leave us with 5x, and we want to bring down this negative 7. So this becomes minus 7. Again, what times x will give us 5x? We need this to be plus 5. So that we get minus 5x minus 5. We are multiplying 5 to this x minus 1 over here. And this will net us negative 7 plus 5, which is negative 2. What we get from this is 2x plus 5 minus 2 over x minus 1. Now, with long division done, we can finally draw a graph. This graph is the third case where we have a quadratic polynomial as a numerator. The first thing we want to draw is the vertical asymptote at x equals to 1. Next, our oblique asymptote is y equals to 2x plus 5. So let's draw in this oblique asymptote, y equals to 2x plus 5. Since we have k is less than 0, we have to follow this green graph up here where we draw in quadrant 2 and quadrant 4. So let's draw this graph. It tends to this asymptote here. And let's draw the part in quadrant 4. That will be our graph of 2x squared plus 3x minus 7 over x minus 1. Here's a summary sheet for rational functions. Please try to remember all the different shapes of the curves, and remember, for linear numerators and quadratic numerators, you must perform long division before you can start drawing the graph. This is so that we can identify the horizontal asymptote and the oblique asymptote, as well as using the k over here to determine the shape of the graph, whether it's in quadrant 1 and 3 or quadrant 2 and 4. Thank you so much for watching.